Okay, so to work out the theoretical yield of chemical reactions, first of all, we're going to need a balanced chemical equation. Then you're going to have to take the actual quantities you've been given of each reactant and work out, if you used up the entire amount of that reactant, how much product would you make? Rinse and repeat it for the second reactant, third or fourth if applicable, and then compare the two values in terms of mass in grams of product you get, okay? And whichever one is the smallest is going to be your theoretical yield, because that is coming from using up all of the limiting reactant, okay? So first of all, let's get a balanced chemical equation. So we've got CH3 plus O2 forms carbon dioxide and water. Now, this is a combustion reaction. So for any combustion reaction, to balance it, the easiest way is to balance carbon, then hydrogen, then oxygen. So I can see I've got 2 carbons, so I'm going to balance the carbon. To balance the hydrogen, I've got 6 on this side, 2 on this side, so a sneaky 3 is going to cover that, and then add up all my oxygens and then fix it with this guy. So 2 times 2 is 4, plus 3 is 7 oxygens. So little trick, use a fractional coefficient, 7 divided by 2, okay? That should be balanced. So I'm going to multiply everything by 2 to get rid of that 7 over 2. So 2, 7, 4, and 3 should be my balanced stoichiometric equation, okay? So then I'm going to have to get molar masses of each reactant, the ethane and the oxygen, and I've been asked about water, so I'm going to need my molar mass of water as well, okay? So let's just gather some information, okay? So my molar mass of ethane, CH3, so carbon is 12.011 times 2. Just going to write on here 12.011, and then I've got how many hydrogens? I've got 1, 2, 3, 4, 5, 6 times 1.0079 should give me a molar mass of 12.011 times 2 plus 6 times 1.0079 gives me 30.0694 grams. All right, so that's my molar mass. I suppose I should say grams per mole, really, for now. All right, and then I need it for oxygen. O2 is going to be 2 times 15.9994 is going to be 15.9994 times 2 is 31.9988 grams per mole. And then my molar mass of water, H2O. Wow, I'm hitting all the buttons today, aren't I? Is going to be 2 times 1.0079 plus 15.9994. It's going to be about 18.01 or something, right? 2 times 1.0079. Sorry, plus 15.9994. 18.0152 grams per mole to that many sig figs. All right, so then I've got to gather some mole ratios. For every 2 moles of CH3 that react, I will make 3 moles of water, okay? 1 mole ratio, done. For every 7 moles of oxygen that will react, I'm going to make 3 moles of water. Now, that is everything that I'm going to need to be able to answer this question. So I'm just going to stick it up there. Okay, so first thing I'm going to want is to go from mass of CH3 to moles of CH3, CH3 or ethane. Then I'm going to go to the moles of water to the molar the mass of water. Okay, so my conversion factors between mass and moles of CH3 is going to be the molar mass of CH3. Oi. And then between the moles of CH3 and the moles of water is going to be my mole ratio between those two. And then I'm going to need the molar mass of my water to convert between the moles of water and the mass of water. Okay, so let's do it then. The mass of ethane was 0.30 grams. So use the molar mass. Make sure you're including that it is 30.0694 grams for every 1 mole of ethane. So you can see the grams will cancel out, leaving me moles. So I'm here. Okay, And then we want moles of ethane to cancel out. So that's going to go on the bottom. You can leave off the coefficient for a second if you just want to make sure you get them the right way around, that moles of ethane is going to go on the bottom and moles of water is going to go on the top, because it's the moles of ethane that you're going to want to cancel out. So from our mole ratio, we worked out it was 2 moles of ethane to 3 moles of water. So that is a much better approach than just being like, oh, do I times by 3 and divide by 2, or do I times by 2 and divide by 3? If you use your dimensional analysis correctly, you won't need to guess, will you? Because you'll just know. And then finally, we want moles of water to cancel out and to be left with grams of water, using the molar mass of water as a conversion factor. So before you put anything in your calculator, just make sure that everything is cancelling out correctly. So grams cancel out, moles of ethane cancel out, moles of water cancel out. So I'm going to get a number. It's going to be the mass of water that I would get if I had infinite amounts of oxygen to react with and only 0.3 grams of ethane. Okay, so I'm not finished with my calculation yet, just to be clear. Okay, it's very easy to get a number and think you're done. So 0.3 divided by 30.0694 times 3 divided by 2, 3 over 2. Oopsie, I've just put that totally wrong on my phone. Hang on, 0.3 times 1 over, oh, you know what? I need to use a real calculator. Sorry, guys. I was like hoping the backlit screen would be helpful, but it's not. So 0.3 divided by 30.0694 times 3 divided by 2, a real calculator is just so much quicker, times 18.0152, give me 0.2696 blah, 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 grams. We're asked to round to 2 significant digits, so that'll be 0.27 grams. So we're not done yet. We've got to do the same thing for the 0.73 grams of oxygen. So we're going to go from the mass of oxygen to the moles of oxygen to the moles of water to the mass of water. Okay, and then we're going to compare those two masses. Yes, you can just do it on this third step here where you've got the moles of product, but the way I teach it, and I think it saves you time most of the time, is to just go straight forward and calculate the mass in grams while you're doing the calculations. Because, yeah, you can get the limited reactant from the number of moles of product, but if you go straight through and calculate the mass in grams of product, you've also calculated your theoretical yield with not much more effort, okay? So we start with 0.73 grams of oxygen, use the molar mass of oxygen, which was 31.9988 grams per every 1 mole of oxygen. And then we want to convert moles of oxygen, so that's going to go on the bottom, to moles of water. So our ratio was, for every 7 moles of oxygen, you can make 3 moles of water. And then finally, that last step that I was just talking about doesn't take very long to convert moles of water to mass in grams of water, which will give you your theoretical yield. You might as well go ahead and do that. So let's just make sure everything is cancelling correctly. So grams cancels, moles of oxygen cancels, and moles of water cancels. So we're going to get a number. It's going to be the mass in grams of water. Okay, right. 0.73 divided by 31.9988 times 3 divided by 7 times 18.0152. If I've used a calculator correctly, I get 0.1761 blah 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 blah. We're asked for 2 sig figs. That'll be what? 0.18 grams. Okay, 0.18 is less than 0.27. So once you've used up all this oxygen and made 0.18 grams of water, you cannot make any more water. So this guy right here is impossible, can't get, okay? So what we've got is we've got extra CH3, CH3 or ethane than we need to, okay? Oxygen is the limiting reactant because it gets used up first. And when it gets used up, the amount of water we've made is 0.18 grams. That is the theoretical yield. And it is not possible to make any more than the theoretical yield because we've run out of one of the reactants, in this case, oxygen. Okay, so the theoretical yield of water is 0.18 grams.